Hola, hola. With this tutorial, you will learn how to encrypt a message in a specific way using pure data by creating a pure data patch, but you will also learn or you will have an idea of how you can do this using other programming environments. I will start by explaining the components or the classes of this beautiful and simple patch. So first of all, we have to decide what is going to be our key. In my case, it was the heartbeat, a number which I got from a sensor, and I'm gonna represent this in this case with this function for generating random numbers. And then we have here the recording section. It's the section with which we are going to create the message and record the message. This section is the play class with which we are going to reproduce or give a play for the audio message. And this last section is a section where I am receiving the audio signal. Yeah, this graphic is just for visualization, and all the sound is going out through these components, which I'm gonna explain in the end. Okay, so let's talk about this random number. This random number is the number with which you are going to store the message. So let's turn on this. We're starting to count random numbers from 0 to 100, and I'm gonna connect these. So now this random number is gonna be my key, and when I press this rec button, this button is sending three signals. One signal is saying here, okay, you have here two inlets, one inlet here in the left, one inlet here in the right, and in the right inlet you are receiving a number constantly. But when I press the rec button, he's saying, okay, take this second number, this F2, and store it and create a secret message with the name of this second number. Then the second signal is going to start 1 second before, and it's going to start writing over the file. And with the third signal, we are going to say, okay, let's stop recording. After 10 seconds, you can change, for example, this number as 6,000 milliseconds, which is 6 seconds. And let's try. So let's look at the file. You have in a folder, I have here this folder, message encryption, and in the same folder you have the file or the code in pure data. So this software is gonna write and record the files in the same folder. Let's try and look. So it's just recording right now. Okay, now let's disconnect this and let's listen. Let's listen with this number 99, our message. So it's just recording right. It was a small message, but okay. So the thing is that we wrote a message with this number, but this number constantly is changing. That means that whoever is going to open the file, it has to know exactly what is the number of the file. I will play. It took the number 39, but there is no message in 39. And let's explain what is happening with this play sound. With the play sound, I'm calling the same expression to say, okay, let's take your second number and then call the secret message with this number. But if the message doesn't exist, you are not going to open any message. The message is gonna be reproduced after half second, and we are gonna send the message here, and we are gonna visualize the message because I'm sending audio signals here to this tab right, and this tab right is writing in this tab exactly the audio signals. Let's try again. We can record a message again. And we can see here, but the user cannot see with which number we start the message. But we can prove that with the number 80, we can open the message stored in the 80 number. So normally you have these kind of softwares running in a Raspberry Pi or in your computer, but the user is not going to see in which number the message is stored. So in the end, it's gonna be a surprise when you find some message with the number. Okay, so finally we're gonna talk about these components, which are very important because through these components you are listening or controlling the audio signal. You can notice a small difference among all the lines that are connecting each of the components, and here the lines are thinner, so you can notice that the thicker lines are sending audio. Those lines have like a purple color, and so here we have the microphone signal, and we are multiplying this signal to send it first of all to right here. So you say the microphone enter is multiply. I can control here the volume, and here I'm going to write. But also when this object is reading, it sends the signal to this multiplier, and the multiplier it's gonna give us this digital audio signal, which is gonna be converted by the DAC, digital analog converter. And I will say that that's all. So enjoy this patch.